A very good morning to everyone. Today I would like to present this equation. This is it's a circuit, a parallel circuit. Today we will look how we would solve this parallel circuit. So we have to use mesh MESHA analysis to solve this parallel circuit. So this is our first mesh. In this one series circuit, there's a battery and a resistor. So and then the second loop we have a resistor. Third loop resistor and a power supply, and then the fourth is also the same resistor and a battery. So we have to write mesh for each and every loop. So for the first mesh we have our current, which is IS1 is equals to 2 ampere. So in second mesh we have to use our Kirchhoff voltage law. So when we use our Kirchhoff voltage law, we will get for this we will have T2 minus T1, and this would be T2 minus T4, and then this would be T2 minus T3. So when we fill in the equation, we will get an 4 T2 minus 2 T2 minus 2, and then 2 ohms I2 minus 2, and then T2 minus 4. So we will solve this thing, and then for the third mesh we will have an I equals to negative 4 ampere, since the negative, because it's in a different direction, the amperes, because it's from negative to positive, so the value will be negative 4 amperes. In mesh 4 we are using Kirchhoff voltage law again. So we are going clockwise. So I4 times with R3 minus 4 voltage, and then plus with resistor at 5. So we will get an I2 equals to negative 2 voltage plus 2 I4, and when we substitute that first equation, derive the equation and substitute the first equation, we will get an 7 I2 minus 2 I4 equals to 4. And then we have to use substitution. So we substitute this fourth equation into a third one. So when we substitute, we will become 7 negative 2v plus 2i4 minus 2i4 equals to 4. So when we settle the equation, we will get a 1.5 amperes. So now we have to use this 1.5 amperes, which is the value of I4, and substitute in the equation of I2. So we will get the answer for an I2, which is 1 ampere. So for the KCL, Kirchhoff current law at naught, we have to know that if at naught the current going in is same as the current coming out. So I3 plus I1 is equals to I4 plus I2. So when we substitute, we get to find the answer, which is Ix equals to 0.5 amperes. So when we use the Ohm's law, V equals to IR, we will get the number of voltage is 2V. That's the explanation for the first question. Okay, now we are looking at the second series. This is also in a parallel series, and this is way more complicated than that. It looks like that. So first we have to find the KCL at both of the knots. So for knot A, this is our knot A, and this is our knot, second knot. So for the knot A, our equation is IR1 plus IR3 equals to R2 and R4. So you can look at that R1 and R3 are coming in and R4 and R2 are going out. So this represents the knot equation, which is I in is equals to I out. The same thing goes to knot 2. You can see that I4 is coming in and I7 is going out. No. I7 also coming in, and then R6 also coming. R6 is the only thing that's going on. Everything else is coming in. So when we rearrange this KCL formula at two knots, we will get an 1 plus R3 over R1 plus R3 over R2 plus R3 over R4. V1 equals to R3 over R4. V2 equals to Vs2 plus R3 R1 over S1. So when we substitute the values inside the equation, we will get 32 ohms kilo ohm over 16 kilo ohm times with V1 plus 1 plus 32k over 16k plus 32k over 10.67k and 32k over 8k times with V2. So we will get an answer of 18V minus 3V2 equals to 75 voltage. And then there's also another equation, which is negative 2V1 equals to negative 2V1 minus 10V2 equals to 125. So when we substitute these two equations among one another, we will get an answer of V1 equals to 7.58 and V2 equals to 20V. That's it for the second equation, finding out the V1 and V2 value. Thank you.